So, meine Damen und Herren, und jetzt begrüßen Sie mit mir die Preisträgerin des Körber-Preises für die Europäische Wissenschaft 2021, Professor Clare Grey. Clare, I have the feeling that this applause is an applause of a lot of hope, of people who say, you will bring us the solution for a new sustainable future. Is there too much expectation at this moment? Also gibt es, ich mache das noch auf Deutsch, Entschuldigung, ich habe so den Eindruck, dass der Applaus und die Intensität ein bisschen auch geprägt ist von einer Hoffnung, dass Clare Grey uns möglicherweise den oder einen wichtigen Schlüssel für die Nachhaltigkeit der Zukunft geben könnte.
First of all, I hope you'll forgive me for answering in English, if that's okay. The science, as you know, is an international thing, and so it's not just one person who makes the impact. I mean, I think I'm very lucky that I have a particular area that I can focus on with my NMR spectroscopy, which is a degree that is unique, but it is actually the world that will solve this problem, right from the students all the way through to everybody in the street, to making societal changes. So yes, I'm slightly intimidated by the weight on my shoulders, and you know, it's quite unique in fundamental science that you also not only have to work on things in the lab, but you also have to solve the world's problems at the same time. Yes.
Wir haben gestern Abend ein bisschen gesprochen und Clare hatte ein Paper, wo sie im Grunde genommen diese Kernspinntechnik schon als junge Frau angewendet hat. Das ist Grundlagenforschung. Und inzwischen ist diese Hoffnung, die das Ganze noch belastet. Es geht immer noch um Grundlagenforschung. Yesterday we saw you got the point. So, is it still fundamental research which is really your basis?
So what was interesting about that paper was when I did that many years ago now.
When was that, roughly?
Late 80s, early 90s. There was very little application of that method that I developed. And at the time, we were thinking about catalysis and the petroleum industry. And then 20 years later, I saw how I could take that initial discovery that seemed very esoteric and actually use it to study the batteries. And so, was I thinking about it now? Then, no, of course not. I was an undergraduate in the lab. So.
Also was man daran sieht, ist, dass diese Grundlagenforschung, die am Anfang eher fast esoterisch war in einem bestimmten Bereich, dann plötzlich Anwendung fand in dem Verständnis von Batterien. Ich meine, wir alle nutzen Lithium-Batterien in unseren Smartphones, manchmal in unseren Autos. Eine einfache Frage, wie gut versteht man überhaupt heute, wie diese Batterien funktionieren? I mean, how well do we understand these batteries which you're using in everyday life?
We understand many of the processes. I think the challenge you have is that you want a battery to last for 2 years for your phone, 7 years for your car, 20, 40 years for the grid. But these are very highly complex systems. They're chaotic. And what we are not good at is understanding which of the processes will dominate. And that may be because a battery will be used differently. So if it heats up or it's charged too quickly, that results in a different series of degradation processes. So conceptually, we understand the modes of degradation, but being able to predict the lifetime of a battery and what will dominate, I think that's one of the challenges, and that's why a lot of the work we are doing to try and look at diagnostics and ways of looking inside is to sort of help predict the future in a small way.
Also ein wichtiger Punkt ist, sagt Clare, letztlich die Lebensdauer der Batterie wirklich und die Mechanismen, die dazu führen, dass sie verkürzt ist, genauer zu verstehen. Aber ich habe eine andere Frage in dem Kontext. Also wenn ich mir heute angucke, wir haben Antriebe auf der Basis von fossilen Treibstoffen. Stellen wir uns vor, diese Flasche wäre gefüllt mit Benzin. Sie ist es zum Glück nicht. Ich schütte Ihnen nur Wasser ein. Die Energiedichte, die da drin steckt, ist natürlich extrem hoch, wenn es Benzin oder Diesel wäre.
Water, but anyway.
Und eine adäquate Batterie mit einem ähnlichen Speicher wäre wahrscheinlich 10, 15 Mal schwerer als diese Flasche. Hat die Batterietechnologie überhaupt eine Chance, langfristig zu konkurrieren mit diesen klassischen alten fossilen Treibstoffen?
So if I understand your question, so my German is fine when you're simple. When you get more abstract, then I have the not
okay.
Quite,
I'll just.
But it's your question is, am I ever going to have the energy density of not the water but petrol? So I mean that was why in the film you heard about the lithium-ion battery, because that in principle is the technology that has the same energy density. Of lithium is light, oxygen is light. You put them together. But in practice, it's very difficult to beat a petrol because of the energy in a carbon-carbon and a carbon-hydrogen bond. So I think that's why if you look forward and you have a roadmap for climate change, you have batteries that are part of the journey, but ultimately society is going to have to need to rethink chemical fuels and thinking about solar to molecules and put that as part of the story. So I'm optimistic that we have factors of 2 to gain, but you know, if I'm honest, we have to do more things. We have to think about using different, what I would call energy vectors, different molecules to store electricity, because ultimately metals are heavy, and the basis of a lithium-ion battery is a metal oxide on one side and a graphite. And so, you know, again, we are hopeful that the lithium-ion system will help, but we also need to have other channels moving forward.
Also um es kurz zusammenzufassen, es geht einfach darum, dass letztlich Metallhydride schwer sind, die entsprechenden Energiedichten immer noch geringer sein werden, auch in Zukunft zu flüssigen Brennstoffen, chemischen Brennstoffen. Und wenn ich Sie richtig verstehe, sagen Sie, wir müssen in Zukunft sozusagen viele verschiedene Optionen gucken und sollten nicht alles auf möglicherweise eine Karte setzen auf moderne Sauerstoff-Lithium-Batterien. So, do you think that in the future we should sort of, in a more aggressive way, broaden our view to take into account perhaps different solutions? So it won't be one solution for everything, the same battery in my smartphone than the battery storing wind energy. Also sollte man da nicht in Zukunft mehrere Optionen berücksichtigen?
Yeah, I think definitely. I think it's, you know, the goals of climate zero carbon by 2040 or 2050 mean that we have to do 2 things. We have to recognize that some things have to be pushed forward very quickly. So if I have an invention in my lab today, you know, it will take 10 years almost for it to go into the marketplace. I mean, we are moving certain things faster. There are battery discoveries that are so-called drop-in technologies. So you make a change and you can put it into existing technologies. But if you want to do something radical, that has a time scale, and that time scale, unfortunately, is currently about 10 years. But to answer your question more precisely, we absolutely need different options. We need to keep the different players on the table, but we also need to be thinking about when the stage gates are, when do we have to make decisions about how to deploy different things. So at the moment is the time for fundamental science to open up new areas, to assess the sodium-ion batteries as a more sustainable technology. We can get rid of the copper, we can get rid of the cobalt to a large extent, and use iron and manganese. We need to improve our lithium-ion batteries. We need to rethink how we recycle them so that you can pull them apart and they're inherently more safe. And that's, you know, we need to be putting that in place now to achieve 2040, 2050. Talk about redox flow batteries, which is very large battery systems. So I think any sort of strategy that says it's one thing or another is misguided. Ja.
Ich werde das jetzt nicht nur grob zusammenfassen. Es geht einfach um die verschiedenen Optionen, die man genau prüfen muss. Und was mich dabei interessiert ist, auf der einen Seite gibt es Grundlagenforschung, die in gewisser Weise Neugier getrieben ist. Curiosity drives fundamental research. Aber auf der anderen Seite erleben wir, und wir stehen hier in Deutschland in einem Wahljahr, wo wir natürlich den Druck auch durchaus spüren, auch weltweit, dass bedingt durch den Klimawandel wir gezwungen werden, noch einmal die Stöchiometrie unserer Energie, unseres Mixes, unserer Belastung der Atmosphäre zu überdenken. Das ist ein großer Druck. Wie wirkt sich der auf die Grundlagenforschung aus? How does the pressure on climate change sort of feel if you're speaking of, well, fundamental research? Is there too much expectation?
I think actually I see it almost as a luxury and a pleasure, and I'm very lucky that it motivates the students to come and work, and I'm very lucky to have extremely bright students and postdoctoral workers who are motivated by this, and I think it's almost an honor to be in a field where I can work in an area of fundamental science. So I'm very interested in how atoms and molecules move and how they're arranged, but yet I can then see the trajectory through to solving some important problem. And I'm not so arrogant as to say that most of what we do makes that direct impact, but you can at least see a trajectory and put it in the bigger context of solving challenges for humanity. So it is very difficult because even though I do NMR spectroscopy, which for many is very obscure, I'm still expected to know all of the numbers associated with climate change issues and battery efficiency, and as well as my knowledge of NMR spectroscopy and how the pulse sequences work. I have to know it all, at least at one level. But ultimately, it's a pleasure, and I'm honored, and I feel myself very lucky to be in a situation where I can see that connection and make the connections.
Also, es macht Sie stolz auf jeden Fall, und es ist eine glückliche Lage, dass Grundlagenforschung in dem konkreten Fall wirklich kombiniert oder gelingt ist an die Anwendung. Wenn Journalisten kommen, glaube ich, in heutigen Zeiten ist die zweite Frage an Sie, wie realistisch sehen Sie die Chancen, dass wir tatsächlich diese Energiewende, und dafür sind Batterien ein neuralgischer Punkt oder Energiespeicher, dass wir das, ich sag mal, bis zum Jahr 2030, 2040, 2050 schaffen. Wenn ich Sie als Wissenschaftlerin frage, was ist Ihr Guess? Sagen Sie, die Politik übertreibt oder ist zu euphorisch, oder sagen Sie, das geht vielleicht schneller?
Can you articulate that
I will
in English?
ask. Normally, journalists, the second question would be, looking at the roadmap, looking at climate change, we all see the necessity to sort of, change, and batteries or energy storage is one very important piece of that new picture. If you look at the scenarios, 2030, 2040, 2050, how realistic is that from your perspective?
Are you talking about specifically the batteries, or you mean the whole of the societal change?
The whole, because batteries are going to be one very important part, I think so, of a change.
You can call me naive, but I personally think we have no choice. That we as a society have to do something about it. And I think that there are road maps that we can predict, and that there's some that we can't. But as a society, we're now in the position where we have to get going and enable it. And that means doing the fundamental science. It means doing the so-called demonstration projects, where you demonstrate how putting a new technology, whether it's a new battery, whether it's a fuel cell, or some aspect on the grid, changes society or changes the way industry works. It means making the industries like steel, cement more green. That has to be done now. And then that has to be coupled with societal awareness. And so I think that's sometimes why demonstration projects are important, because that then changes the way that people think. Because if we are going to ask of the world the requirement to behave differently, that's a significant challenge, particularly when we're coming out of COVID, where humanity's had a lot of restrictions. It's made us rethink how we do things, but for many to be then told that you can't travel or you can't do this is a big ask. So we need the fundamental science, we need the engineering, and we also need to think about society. And so that involves the people in humanities, and it's a global effort. And we also need to think about how we do this in the West, but also how we enable everybody to be lifted up, so that that people have quality of life everywhere, and that has energy implications. And it was mentioned earlier on that Germany will have will need 5 times more electricity for the grid. I think those numbers can be questioned. In the UK, the number is 2, and maybe you could argue that's because we don't have any industries, or not as many industries in Germany, but it's also about how to do things more smartly. So if you roll out the life of the same sort of lifestyle, then you're going to need 2 times, 3 times, 4 times more electricity. But if you do things in smart ways and you have more smart metering, then the requirements become less. So it's a holistic thing. It's not just one thing. It's putting the whole piece together.
Also wenn man diesen holistischen Gedanken betrachtet mit all den verschiedenen Facetten und natürlich in gewisser Weise dem Bedürfnis von Menschen immer noch zum Beispiel zu reisen, also wir werden nicht die Vollbremsung machen und zu, ich sag mal, bewussten Mönchen werden, deren Energiekonsum nach unten geht. Weltweit, global, sieht man Entwicklungen, die eigentlich unser Lifestyle als Vorbild haben. Wenn wir uns Batterieforschung, wenn wir uns Entwicklungen in dem Bereich anschauen, Sie haben einen sehr guten Überblick weltweit. Wie gut sind zum Beispiel Länder wie China? Also erwarten wir, dass die neuen Lösungen aus dem europäischen Raum kommen, was wir natürlich alle hoffen? Ja. Oder stehen die Chancen vielleicht eher, dass Länder wie China uns in Zukunft eher überraschen werden?
Help me out.
If we look at the development, we have Europe, but we have also other countries like China. And if you look at the technologies emerging in these countries, my question is, are we still the main players, or will we see perhaps really startling new approaches coming in from, for example, China?
Well, those are very political questions. I mean, how can you not deny the importance of other players? And China, for example, has put tremendous amounts of money at a state level into new technologies. And they have just announced a month or so ago that they're investing in sodium-ion batteries. And that's a very clear message to the market that will go ahead. And India has efforts in renewables and in car manufacturing. So, we're a part of a global, I don't want to use the word race, but we're part of a global activity, though tensioned with that is the need to do things locally and to worry about the sourcing of materials. And the thing about batteries that's different from many other industries is that you can't ship them very safely. So there's a real incentive to produce them locally. And so we have to be aware of the global aspects, but also the local aspects.
Also es gibt den globalen Aspekt und es gibt den lokalen Aspekt, weil zum Beispiel der Transport von Batterien natürlich einfach problematisch ist. Das weiß jeder, der im Flugzeug ist. Da darf man auch nicht zu große Batterien mitnehmen. Es ist ein Preis für die europäische Wissenschaft. Claire, erstens mal sind wir sehr froh und ich kann mit vollem Herzen den Worten von Herrn Dittmar zustimmen, dass Europa auf der Wissenschaftskarte immer noch united ist. Was ist der große Vorteil von Europa als Wissenschaftsstandort? What is the big advantage of Europe as a science continent?
Well, I started as an academic in the US, and then I came back to Cambridge in 2009, as was said. And for me, one of the reasons I wanted to come back was because of the European science, and that very much it is a community that works together. And in the US, as a professor, there's very much a sort of pyramidal system where you sit there at the top and you have your own little camp, whereas that's not the case in Europe. There's a much more of an emphasis on doing things together. I mean, the US is also changing, recognizing the fact that the type of complexity that I do in science, and some of my colleagues also on the Körber committee do as well, cannot be done by an individual. We need big pieces of equipment, and so Hamburg has obviously its center for DAISY for research. And when I came to here, I asked my research students, what should I do in Hamburg? And many of them, one Argentinian, one German, said, you know, you should do this. And their advice was based on having to come to Hamburg to do experiments. And then in the evenings, when they had a few hours off, they were in town. So I'm giving you a very long response to your question, but I think, you know, it's the scientific community in Europe is very special. And you know that we have to form communities. We have to do things together if we're going to make impact on solving some very difficult problems. And so I think that's very much why I like being part of Europe.
Also Zusammenarbeit in Europa als eine besondere gute Qualität, eine besondere Stärke. Dennoch ist Europa ein sehr heterogenes Gebilde, wenn ich das mal mit China oder mit den USA vergleiche. Ist gerade im Bereich der Wissenschaft diese Unity of Europe etwas, was vielleicht gerade in Zeiten, wo man dann zweifelt, wichtig ist? Denn wir haben ja großartige Beispiele, wo europäische Wissenschaft, europäische Forschungszentren, CERN, DAISY, der Röntgenlaser hier und so weiter, wo Europa eigentlich seine Stärke dadurch entwickelt. Müssen wir das auch in der Wissenschaft stärker betonen, dass Europa diese Besonderheit hat? Should scientists stress out these strengths in Europe? Because many people tend to go to the US, but Europe as a continent is something quite productive, quite innovative, quite inspiring.
Yeah, I mean, I think that one should also think about travel beyond Europe, and going to the US and seeing different ways of doing things is also important. And I think moving forward, it will not just be going to the US, it will be going to Asia and many parts of the world, and also to Africa and to South America. So I think, yes, Europe, but also yes, global, because we are part of a global community. But no, I very much agree, and I think that also the facilities in DAISY and ILL is very important for material science, and also it's quite fun. I mean, I think one thing that being a scientist in the last 2 years has sort of brought that home is that we have a community, and there's something very joyful and fun to see people and meet people around the world. So.
Also die Freude der Luxus, aber dennoch die Freude der Wissenschaftscommunity ist einfach etwas, was kennzeichnend ist. Ich komme zum Schluss und ich frage Sie, wenn wir uns, gesetzt den Fall, das klappt, in 20 Jahren wiedersehen, okay? Ja. Werde ich dann ein Smartphone haben, was ich vielleicht nur jede Woche aufladen muss? Und sind Sie vielleicht dann, keine Ahnung, mit einem Elektroflugzeug von Cambridge nach Hamburg geflogen? Geben Sie uns einen Ausblick. Was ist Ihrer Meinung nach eine Abschätzung in 20 Jahren?
You asked me what my
yes.
vision of the world in 20 years is. So I'm not sure that the smartphone that will last for a week is part of my vision, because I think the problem is, as we as consumers, as the batteries get better, people want more from their phone. And so, there's sort of a frustration with the poor batteries, but it's partly because the phones have just become so much more demanding. I mean, I think in terms of the sort of portable electronics, my vision is that the battery will almost become an irrelevancy, is that, I will have put my phone down and it will have charged via some remote charging so that life will be much more seamless. My vision is not to fly necessarily on an electric plane from Hamburg to London, because I am conscious of some of the resource issues of that. I think electric planes have a potential, but they will be in small portable devices, small planes for a few people. So my vision is that we will have found more sustainable ways of increasing uses of transport. We will have had more sustainable ways of storing electricity, and we will have enabled a larger fraction of the world to enjoy some of the luxuries that we have here.
Also die Welt wird nachhaltiger werden und hopefully we will all the same meet back in 20 years, physically, not virtually. Vielen Dank an dieser Stelle. Wir werden gleich zur Zeremonie der Preisverleihung kommen. Zuvor habe ich noch die Freude, mit Tatjana König und Martin Stadtmann zu sprechen. Aber an dieser Stelle vielen Dank und einen großen Applaus an Clare Grey.
Vielen Dank.
You have a seat? I'll call you back.